Hello everyone, welcome to another access control coaching session. It's already that time. Today we are going to be talking about ADA door compliance and integration. So we are going to be covering from the very basics what ADA is and what it means, and then we're going to get into the more technical side of things on the components of an ADA system, how to integrate it into a PDK system, and how to troubleshoot it accordingly. My name is Cole Nebeker. I'm the Training and Events Manager here at PDK. So as you have questions, as they come to you, please leave them in the comments. There is about a 30-second delay between what I am saying and when it actually appears on YouTube. So leave those questions early, because at the end, when we are wrapping up, we're going to have that buffer interfering. So let's go ahead and jump into the slide deck here. And we're going to start with what ADA is. So ADA is going to be the American with Disabilities Act. It's a federal law that prohibits discrimination against people with disabilities. This includes the discrimination on the basis of disability, just like you might with civil rights and race, color, age, origin, religion, all of those things, right? And what it means is that people with disabilities have the same opportunities as everyone. So what that means from a door standpoint is that we are going to require accessible places. So what that looks like from a door standpoint is that anybody, regardless of whether they, are in a wheelchair or maybe walk with a cane, any kind of disability, they can still get through that door. So the ADA standards in sections 309 and 404, you're welcome to go look at that, or you can just take my word for it. That outlines the requirements for those accessible doors. ADA buttons and the automatic doors are used to make the doors easily and independently accessible. And so there's a whole outline of what that looks like, space available, where the button goes, how easy it is to open the door with how much pressure. But the gist of this is that you don't necessarily always need automatic doors and ADA buttons, but they're mandatory when an accessible route can't be opened by individuals with disabilities using the minimum required effort. Again, that's all outlined in sections 309 and 404, a few other places as well. So there's a few components that may make a door ADA accessible. What you probably recognize would be the operator, that is the motor, the arm, and the controller associated with opening the door. But probably the more identifiable piece is going to be the push plate. So it's what you see there on the screen that indicates that it is an ADA accessible entrance, so it's easy to identify and find, and they can just push that in order to open up a door. Then you, of course, need to have access control. That's not always necessary if the door doesn't inherently have any kind of security measures in place, but the access control system is going to be the other automated piece of the ADA system that actually unlocks the door so that when you push that button, the door actually unlocks before it opens. So we're going to start really simple here. When we're integrating an ADA system, you're going to need to tie it through the access control system. The first piece you do, and this isn't the whole picture, all right, we're starting small and we're going to build on this. The first piece is going to be that outside button. So you can see it labeled there on the bottom left. It is tied into both the ADA motor and the PDK board. And the reason for that is because the outside button, we don't just want it to open the door without interacting with the access control system. That would mean that anybody that came along in the dead of night could hit that button and it would just open the door, which is obviously not ideal. So we're going to tie it through the PDK system, and the first thing I want to note is that you are going to need 2 ports for this, or 2 relays, I should say. So we're going to tie the outside button through the common and normally open so that when access is allowed through that door, this relay flips and connects the common and normally open, therefore completing the circuit. So outside button, ADA motor, and PDK system working in conjunction with each other so that when the relay is activated, the full circuit is complete. The next piece we need to integrate is the inside button. So you can see both the outside and the inside button are both tied to the ADA motor, that operator that I showed on the previous screen, and that is going to be controlling the motor of the door. So the outside button needs to be tied through the PDK system. The inside one can just go directly to the ADA motor. We want people to easily be able to get out of the building. It doesn't matter if it's the dead of night. If somebody's locked inside that building, we obviously want them to be able to get out of that building. Now you'll also notice we have a couple of purple lines going up to the B and negative. So we do still have it tied into the PDK system, but the reasoning for that is to report on the inside button as effectively a REX, and I'm going to explain why we do that later. But we have the inside button tied directly to the ADA motor, so if we push that button, that motor is going to open. However, we do still need a B and a negative because we need to unlock the strike. The door's not going to open unless we have the strike unlocking it, or the mag lock, I should say. So here's a more comprehensive picture, and I have a couple of different scenarios outlined. All right, the first thing, we've still got the exact same outside, inside, and ADA motor configuration. That's all the exact same as you saw on the previous page. We've now added two more components. We've added a reader on the exterior of the building, and we've added a strike in this scenario. You'll also notice we have a jumper on the bus and negative, and that is because we're powering the strike off of the PDK board. I'm going to show you what it looks like when we power it using an external power supply, because that does change things a little bit. But just notice that it's fundamentally very simple. We've got the outside button, which needs permission from the PDK board to activate the ADM motor, and we have the inside button using the permission of the PDK board to activate both relays. It needs to activate both relays at the same time. It doesn't do us any good to activate the ADA motor if, when we activate the ADA motor, the strike is not opened at the same time, because then the ADA motor just pushes against the strike, and it's bad for both pieces of equipment. So we need to program the system to release both the ADA motor and the strike at the exact same time, and that is why we have the inside button tied into the B and negative. So you'll see the strike is tied in as a basic strike setup. We have it tied into the positive and most typically into the normally open of the PDK relay with that jumper on the negative and bus. So we have a full circuit on the strike when the relay is activated. Now there's still some programming that needs to be done, because as it currently stands, if we hit that inside button, it's going to activate the ADA motor, but we don't have any programming in place to release the strike at the same time. So we need to release that strike and port 1 at the exact same time. So this is the programming that you will do. You'll notice everything here is exactly the same, just in a slightly different position to fit the wording here on the sides. We're going to first create a group event rule, and we're going to say when access is allowed, we are going to open/close. So the source device is going to be the door device, and the target device is going to be the I/O device, so that it allows us to activate the button from the outside of the building. We're going to focus on the outside. That's the secure side of the door. So when we activate the door device, the I/O device opens as well, and of course the door device opens at that same time. That's just a default part of the programming. We need to set both to have the same dwell time, otherwise we're going to have a discrepancy in the motor versus the button activation, and that's not going to go well for us. We'll also need a system event rule, which is doing the inside button. And that one's going to be on Rex open, open/close, or on Rex close. It depends on the button you have. So we've opted with the on Rex open. The source device and the target device are both going to be the door device, because the door device has both the door device and that inside button connected to it. So in that case, the generic I/O device, which we're using for the outside button, is not applicable in this instance. Now you see a little box in the bottom right which indicates that any auto opens applied to the door must also be applied to the I/O. And the reason for that is because if you do not apply an auto open to both the inside and the outside button, then the inside button will work, but the outside button will not. Now let's get a little more complex here. All right, we are now using a third-party power supply. So all that really changes is going to be where the positive is being pulled from. The relay, instead of being a wet contact, is now a dry contact, so you can see there's no bus, no jumper on the bus. So we tie one end of the negative into the normally closed or normally open. In this case, more probably it's going to be the normally open because it's a strike, and we tie the negative of the power supply into the common of the relay. But again, the same programming still applies. We are still going to program both a group event and a system event so that we can make sure that both the outside and inside buttons work in conjunction with each other to open that door. Now, this is where it starts to look very busy, but it's really very similar, I promise. So we are now doing a third-party power supply with a REX also in line with that, let's say that mag lock in this instance. So let's pretend this is a mag lock setup. We're going to tie the positive of the mag lock down to the third-party power supply. Keep in mind the outside button, the inside button, the ADA motor, and the reader, those are still all in the same place with the exact same programming, all right? Let's just differentiate between them so that we don't confuse ourselves. The outside button, ADA motor, reader, and inside button are still doing their own thing, the exact same thing that we programmed them to do on the previous page. The thing that changes now is how we make sure that the mag lock is tied in line with the REX. We may need more than just the inside button acting as a REX. We may also need an actual REX to release that door. So positive of the mag lock going down to the positive of the third-party power supply. The negative then follows the exact same configuration we would always follow with a mag lock when we tie it in line. We would go to the common or normally closed of the REX, and then we take the normally closed of that REX and go up to the common of the PDK relay. The only other thing we need to do at that point is take the negative of the mag lock and tie it up into the relay as well to complete the circuit. So in the case of the mag lock, we would tie that negative up into the normally closed of the relay. I know it sounds like a lot, but that's what this diagram is here for. It's completely independent of the functional parts of the other part of the ADA system. You still do need to program the lock to release at the same time that the motor is activated, but that's the purpose of the programming that we did in group and system events. That is making sure that the lock releases at the same time that the REX input from either the inside button or outside button released as well. Now, I've mentioned system events and group events a couple times now, and this is where we get into the programming for the system. What we're going to do is we're going to program both. We still need to grant access to that door just like we always do. So that would be a standard group rule or access rule written within the person or the group. But the group event is a little bit different, and I do have a video showing you how to program this ADA group event. You're going to need to align the system event with the user access rules. So you need to write an access event that allows users, when allowed, to open and close the relay that the operator motor is connected to at the same time as the lock. So if you don't do that, then you have, again, a discrepancy between the motor and the lock. And when you have that discrepancy, it pushes against the lock before the lock's been released. So you may need to tinker around with delay times or dwell times to make sure that those line up. Your system event, regardless of how it's wired, is going to program a system rule that tells PDK's relay how to behave upon certain inputs. So this is going to be very similar to any other REX rule that you've programmed in the software, where you say, hey, when this REX input is detected, you need to open and close the relay associated with the lock. So functionally, we can think of the ADA button as a REX. When we treat it as a REX, it becomes much simpler to just say, oh, well, when we receive this input, open and close this other input. And this is also kind of the part that I think gets people confused sometimes with the two ports. You are going to cross-target doors across those two ports. And that's where group and system events become very important, because you may have different source and target devices between these rules. Lots of times people just program the source device to be the same as the target device and make it really simple. In this case, you do sometimes have to change the source and target devices to be different from each other. But again, don't worry about that. We're going to show that in a video. So now that we have those basics out of the way, we are going to pull open this video to show you how the programming actually takes place. We're going to cover three things. We're going to cover group events, which are going to be access events. We're going to program system events, and we are also going to program auto open because that's an important piece of all this. If you forget to program the auto open on both devices, you're going to have one device open and the other one not open at a certain time, and it's just going to be a whole mess. So let's get into the video here. So we are going to start in the configuration page, where I'm going to show you kind of what a generic I/O looks like. So when we add a device, you can see we have the usual door gate, but we're going to scroll down and hit I/O device and I/O device. And that I/O device is your generic I/O device. I know it doesn't say generic in front of it, but that just means that you don't get billed for it, and it's a little more limited in functionality. However, generic I/O devices accomplish everything that we want to do here. They're targetable within system and group events. So we're going to go ahead and name it. And I'm going to be very descriptive here. Obviously, you probably wouldn't be this descriptive in a real-life application. But you can see generic I/O device, outside button / motor. We're going to select the connection and set the port number. And I changed the icon here just to be a little more, a little easier to follow. So you can see I have everything programmed in here. I don't need to change anything else. That is it. So we're also going to program the back door to be the ADA door. Again, nothing really needs to change here. Make sure that the REX is enabled, because the inside button is going to act as a REX. I just changed it to backdoor ADA so we understood which door we're working with. Now what we're going to do is create a new group, and we're going to label it the ADA group. When we hit save, you of course are going to have to program a usual access rule so that people can get through the door. I don't cover that in this video. In hindsight, I probably should have covered that in a little more detail, but you will still need to have access rules associated with the door so people can get through the door. It doesn't do us any good to program an if allowed statement if nobody's actually been programmed to be allowed through that door. So we're going to go up top and hit event. So this is a group event. We're going to name it something descriptive, ADA button allow. And I'm going to say when allowed, open / close. And what we need to do is receive an input from the back door, which actually has the reader on it. And we need to target the outside button and motor. And the reason for that is because without that, we are not going to receive a command to unlock or activate the motor. So the door will unlock, but the motor itself won't activate, because the circuit between the outside button and the motor is not completed. I hope that makes sense. I'm going to repeat it again just in case it didn't. What we need to do is we need to program it so that when the door relay is activated, not only does the strike or the mag lock unlock, we also need to complete the circuit. If you go back to my drawings, you'll recall that we had to complete a circuit using the generic I/O device in order to allow that outside button to be activated. If we skip this step in the programming, that circuit on the outside button is never completed, meaning that you can't activate the motor from the outside. That's why this rule is important. Now, we are going to set the dwell time to 3 seconds. You may need to tinker around with that a little bit, and we're going to set the schedule to always. So you can see here just highlighting the importance of those. Now we need to go and program a system event. We need to make it so that we can activate the motor in the case that the inside button is pushed. We have it tied into the Rex input. So we do on Rex open or on Rex close, just depends on what kind of contact it is, if you have any control over the relay. We're going to do on Rex open, open/close. Now getting into the source and target devices, we again are going to pull from the ADA door itself. That is where the Rex is tied in, and we're going to target the same source device. We're going to set the relay time to 3 seconds. Again, you can interact with that how you choose. And finally, we're going to do an auto open for the ADA door. We just need to make sure that both of these are activated to activate at the same time. That was a weird way of saying that. We need to make sure that both the generic I/O device and the door itself are set to activate at the exact same time. The reason for that is because if one of these activates, either A, the motor pushes against the lock, or the lock unlocks and the motor doesn't. So we need to make sure that they both activate at the exact same time, which will occur, and they will both activate at the same time. And then from there, we can select a schedule and say, hey, we want this door open from 8 a.m. to 5 p.m. Keep in mind, this is military time. And when we hit add, now we have Monday through Friday, 8 a.m. to 5 p.m. Both of those will open at the same time, meaning that anybody can just push the outside button, and the door will both unlock and, well, I guess it wouldn't unlock in that case because it's open, but it would automatically open the door. I know that's a lot. I'm sorry, I'm moving quite fast through that, but go back and review any pieces that didn't make sense. I put those wiring diagrams up to hopefully make it make more sense. The first three kind of show the progression of how you wire it. You first wire the outside button, and then you tie the inside button, and then you add the reader, and then you add the locking hardware to all of that. I wanted to kind of show the natural progression of this door. It looks like a lot. When you get to the last picture and it shows, I've got it pulled up here, we've got 1, 2, 3, 4, 5, 6, 7 items tied into it. It feels a little overwhelming, but just break it into those simple categories. We have the outside button tied into the motor, which is tied into a generic I/O device, so that when we activate that generic I/O device, it allows you to open the outside door. And then at the same time, we have the inside button tied into the locking hardware there, so that when and then we program both of them to be tied together so that they both work in conjunction with each other. And eventually you have this cohesive system that all works together in unison to work together. Keep in mind, for the programming, you do need a group event, a system event, and if applicable, the auto open schedule programmed to all work in unison with each other so that both of those ports work at the exact same time as each other. That's the key. You need both of those ports to work in conjunction with each other at the same time so that that door unlocks. Now, in terms of troubleshooting, I think probably the most common thing I've heard on troubleshooting in regards to ADA doors is timing. The timing is the trickiest part, in my opinion, maybe secondarily to the wiring of it. You may need to add delays or dwells in order to get everything to line up. If there's any kind of natural delay in the locking hardware or the ADA button or the ADA motor, you're going to have a bad time. So you may need to go into PDK secondarily after the fact and change the delay time on the relay to alter the timing of the process. The most common, I think, is when the operator activates before, say, the maglock or the strike, and that causes a great deal of strain on the locking hardware. You don't want that. So you may want to add a little bit of a delay on the operator itself to give time for the maglock to unlock and therefore open up the door. So with that said, that's really the gist of it. I don't see any comments here yet. If you do have any questions, feel free to drop them in the comment section now. I'm going to drone on a little bit to give you a little bit of time. But ADA is very important and very integral to parts of access control installations. It's one thing to have just the buttons tied into the motors, because that's very straightforward. I mean, all you have the button do is activate the motor and the door opens. But once you add that locking mechanism in there, that's where it gets a little bit tricky, and you need to be familiar with how relays work. So go back, review those wiring diagrams. It is specific to PDK in the instance of those wiring diagrams, but you may find a lot of overlap in, regardless of what kind of installation you're doing. You might see a lot of overlap in how that relay logic works. So I still don't see any questions. I don't know if I droned on there for quite 30 seconds, but I'm going to assume we don't have any questions. If you do happen to have any questions, the PDK support team is very knowledgeable on ADA, and they'll be able to help you out with this. You can reach out to them at 801-317-8802, which is the general line, and they're option 2, I think. I always forget if they're 1 or 2. I think they're 2. Or you can reach out to your sales rep, and they can help you design a system with ADA doors in mind. Again, you need 2 ports per relay. Not per relay, per ADA door. You are going to need 2 ports per ADA door. So make sure to account for that. It might make a lot of sense to go with an A8 in some instances, because you're just working with generic I/O devices. All right, so we will have another session in, what month is it? It's July already, in August. We are going to have it the first Tuesday in August. So be here next time for our next coaching session. Be sure to like and subscribe so that we can continue to improve. Oh, option 2. Thanks, Sam. Sam's on our support team. He's here for the save. Support is option 2. 801-317-8802, option 2. So like, subscribe, so we can continue bringing this content to you. And if you have any questions, reach out to our team so we can help you out. We'll catch you next time.